Here are the answers for problems 1 and 2, and then I'll be going over them in a second. For problem 1, we are given velocity initial, which is 20 meters per second, and then we know that it's decreasing by 4 meters per second. And then we are also given the time, which is 5 seconds. To solve this problem, we're going to use a motion chart that will have time, velocity, and change in x, or delta x. So first, starting with the time column, we're going to go from 0 to 5 seconds because that's our time increments. Then we can put in our velocity because we're going to start with 20 and decrease it by 4 every second. To fill in the column for change in x, we're going to use the formula delta x equals velocity initial times 1/2 times acceleration times time squared. So we're going to go in and apply that formula to every single second, starting from 1 and going through 5, and changing the time to fit that specific second. Now we have a complete motion chart for this problem. For our next problem, we are given our initial speed, which is 30 meters per second. We also know that at a certain point the cannonball is going to hit a maximum height and have to come back down. That means that once the cannonball hits its maximum velocity, it will have to come back down, and the change in x will reflect our previous answers to show that the ball is coming back down but increasing in speed. So just like our first problem, we're going to go ahead and plug in our chart with the time, and it'll be between 0 and 6 seconds. Then we can plug in our velocity, which will start with 30, and then we'll decrease it by 10 each time because of gravity, and acceleration due to gravity is -10 meters per second squared. To find the change in x, we're going to be using the formula change in y equals velocity initial times time plus 1/2 acceleration times seconds squared. And we're going to use that formula by plugging in each one of the seconds that we have into it, so starting with 1 and then going all the way to 6 to find which one is our maximum velocity